Guys, so we've been studying sequences and series. You've been studying arithmetic and geometric sequences and series. This video is designed to be a little bit of a review of that, and also just a little bit of an introduction to computer programming and some coding. I think that's a useful skill for y'all to have, and I'm by no means an expert, but I wanted to give you a little bit of exposure to it so that you could sort of see if it's something you'd be interested in pursuing more later down the road. And some of you may have had experience with it before. Some of you may have never even thought about computer programming, and that's totally fine. We're just going to go through some basic stuff, and I'll walk you through all of it. So, but first, let's do a quick recap of our sequences and series. So, remember, a sequence is just a list of numbers, like the one I've got right here. So, go ahead and tell me, is this a geometric or an arithmetic sequence? All right. So, if you said geometric, you were correct. This is a geometric sequence of numbers, and that is because from each consecutive term to the next one, I'm multiplying by a common ratio, multiplying by the same number each time. So go ahead and tell me, what's that common ratio? Good. So the common ratio for this this sequence ratio is going to be equal to 3. So 3 is the number that I'm multiplying each time to get to the next term. So I multiply times 3 times 3 times 3. So 9 times 3 gives me 27. 27 times 3 gives me 81. And 81 times 3 gives me 243. So that is our common ratio. And so there's a couple of different ways that we could write a formula for this sequence right here. So go ahead and choose the correct explicit formula for this sequence. All right, so remember, when we're trying to define the formula for a sequence, what we're essentially doing is we're assigning something called an index to each term. So we're saying that for all of, so this sequence right here, this list of numbers is all of the numbers a sub n for n is equal to 1, from n is equal to 1 to n is equal to 6. And what I mean by that is that, so this first term right here, the first term is where n is equal to 1. The second term, that's where n is equal to 2, right? Third term, that's where n is equal to 3. And all this is going to come in handy in a bit when we start using the computer to solve some of this. But each term is assigned an index. And what we're basically saying is for all of these n's from n equals 1 to n equals 6, so we have 6 terms, what is the formula for any term a sub n? So what is the formula? If I wanted to know any term from 1 to 6, what's the formula for that? And so we first start with our first term right here, so 1, so we're multiplying by 1 is our first term, and then times our common ratio, which we said was 3, to the power of n minus 1. So this is not to the power of n, it's to the power of n minus 1. And you can check that by looking at the first term right here. So if I wanted to know what a sub 1 was, if I was looking for the term a sub 1, and I plugged in, so I'm going to plug in my, 1 times 3 to the, so if I plugged in 1 times 3 to the n power, that would be 1 times 3 to the n equals 1, or the first power. So if I plugged in 1 times 3 to the first power, that's going to be 1 times 3, which is 3. But that is not the first term of the sequence, that's the second term. So what I need is a way to define the first term, and that's why we have the n minus 1, because the n minus 1 means that for the first term, we're multiplying 1 times 3 to the 1 minus 1 power, or 1 times 3 to the 0 power. 3 to the 0 power is just 1, so that gives me the correct first term of this sequence, which was 1. So this would be our explicit formula for this geometric sequence. So now go ahead and choose the correct recursive formula. Remember, the recursive formula is where we use the previous term in order to define the next term. All right, so just like we had an explicit formula, we can also have a recursive formula for a geometric sequence. And that's just going to, like I said, it's going to use the previous term in order to define the next term. So we start out and we say, all right, our first term, we're giving it to you. We're saying the first term is a sub 1 is equal to 1. So this is the term where n equals 1. So in other words, when n equals 1, a sub 1 is 1, or the first term is 1. The output is 1. And the reason I'm using this sort of language, you'll see in a minute when we start using the computer. Okay, so we defined our first term. Now we need a formula for any other term, a sub n. So just like we did before, we need a formula for a sub n and we're going to use the previous term to define it. So we're going to use a sub n minus 1, or the term before a sub n. So let me get a different color here. So we need a sub n minus 1. So this is the term that comes before a sub n, right? If this is the fourth term, then a sub n minus 1 would be the 4 minus 1, or the third term. And then we're going to multiply that by our common ratio of 3, right? So we're multiplying each term by 3 to get the next term. 9 is 3 times 3. 27 is 9 times 3. So we're taking the previous term and we're multiplying by 3 to get the next term. And we can use this to verify as well, or we can check our work and make sure that we got it right. And if I wanted to find what a sub 4 was, then I would go and find what a sub 4 minus 1, which is a sub 3, and then multiply that by 3. So this would be a sub 4 is equal to a sub 3 times 3. A sub 3, if we go back up here, the third term of the sequence where n equals 3 is 9. So I would take this number right here is 9. So 9 times 3 gives me 27, which is the fourth term of the sequence. So this would be our recursive definition for this sequence right here. So this is nice, right? We've got a formula that can tell us any of the terms of the sequence. We can plug in any value of n and get whatever term we're looking for, which is helpful. But we could also let the computer do all that work for us. And so let's go ahead and just talk about a few things. So this is a Python compiler. There's many versions of this. This is a programming sort of environment. And we're going to use the programming language of Python for now. That's a pretty good beginner programming language. And again, some of you might have experience with this. Some of you may have no idea what I'm talking about. This is just meant to be a brief introduction to sort of get your feet wet and kind of see a few things about programming that's helpful. So basically what you're looking at, right? So over here on the left side, this is where you type your code. And then you click run, and the computer, and this isn't going to mean anything, but the computer does whatever you told it to do over here in the white area. And then on this side, it executes it and gives you the output, whatever the output of your code should be. So if you think about, like, if you're a programmer for Facebook, what your job is every day is you go in and you write code over here like this, and you tell the computer, all right, if somebody clicks on, the message icon, then you pop up the messages window, and then over here, this is what the user would see. So the user looks over here and clicks on the messages icon, and then they see the window pop up. The computer does whatever you told it to do. So if you want to sort of think about it that way, the inputs go on this side, and then whatever the computer does, the output comes out over here. So let's just take our list of numbers that we looked at a minute ago, our geometric sequence. And we said that it was 1, 3, 9, 27, 81, and 243. So I'm going to just type that sequence out again. Okay. And by the way, so if you want to follow along, I will post the link to this online compiler, and you can sort of mess around with it yourself. I think that's probably one of the best ways to learn how to do this stuff, is to actually try it and mess around with it, get things wrong, and figure it out. So I'll post the link. You're welcome to follow along as we're doing this. So all I did here was type in that list of numbers. And so if I click run, nothing happens. And nothing happens because computers are very literal, and so they only do what you tell them to do. And so far, I haven't told the computer to actually do anything. All I did was I gave it a list of numbers, and it was like, okay, great, that's a list of numbers. But I didn't tell it what to do with that list of numbers. So if I wanted to display the list of numbers over here on the output screen, what I'm going to have to do is I'm going to have to tell it to print those numbers. Print is the command in Python that tells the computer, all right, I want you to display whatever's inside of these parentheses in the screen over here. So now if I click run, now it's going to display my numbers on the right side. So print tells the computer what to do with whatever's inside of these parentheses. It tells it that I want you to display that information on this screen. So like I said, we can use the computer to sort of do a lot of this work for us. And I'm going to show you what I mean. So let's just say I asked you to find the 7th term of the sequence. So right now we're looking at a sequence with 6 terms, and I want to find what the 7th term is. So I'm going to say term 7 is equal to what? Well, I'm going to let the computer figure it out for me, and the way I'm going to do that is I'm going to go back to our recursive formula that we defined, and we said that whatever term you're looking for in this sequence is equal to the previous term times 3. So I'm going to take, okay, if I want to know what term 7 is, then I'm going to take the 6th term, which 1, 2, 3, 4, 5, 6 was 243, and I'm going to multiply it by 3. So multiplying in Python is just the star symbol, just like it is in many other programs. Okay, so that should give me the 7th term. So I'm going to click run, and nothing happened. So why didn't anything show up? Okay, good. So nothing showed up because all right, good. So nothing showed up because I didn't tell the computer what to do with this information. All I said was, take this term 7 right here. We call this a variable. And I'm going to define this variable to be 243 times 3. Okay, and the computer said, that's great, I got that. But it didn't do anything because I didn't tell it to print that information. So if I want it to print what term 7 actually is, I have to tell it to print that. So now if I type print term 7, it's going to print whatever's in these parentheses here. So it printed 243 times 3, which is 729. So that's great. That just told us the 7th term, but that's not really much better than using a calculator. So what I want you to do now, go ahead on your own and find the 10th term of this sequence. So using the recursive formula we derived, tell me what the 10th term of this sequence is equal to. All right, so if you did this by hand, you probably had to go through and find, all right, well, to find term 10, I need to know the term before term 10 and then multiply it by 3. Well, I don't know what the term before term 10 is. I don't know what term 9 is. And I don't know what term 9 is because in order to find term 9, I need to know what term 8 is. And in order to find term 8, I need to know what term 7 is. So using term 7, you could have found 8 and then 9 and then finally 10. And that probably took you a couple minutes to do all the math and figure that out. But what's nice about computers is that we can use them to do all that math for us much more quickly, like I said, much more efficiently, with far fewer mistakes. So let's talk about how we're going to do that. So we're going to find the 10th term of this sequence, and the way we're going to do that is we're going to use something called a for loop. So when you're programming, you can use something called a for loop, and for this case, I'm gonna start out going from 1 to 10, and I'm going to tell you what I mean by this in just a second. All right, so what a for loop does is it's using the indices or the index of each term of this sequence that we're talking about. So this is saying that for all of the n values from n equals 1 to n equals 10, so n equals 1, n equals 2, n equals 3, I want you to do something. And so in this case, we're going to tell it to do the formula that we derived in order to find what the term is when n equals 1 and what the term is when n equals 2. And that way, eventually, it'll find what the term is when n equals 10, and it'll tell us the 10th term without us having to do all that math. But first, I just want to talk about what a for loop actually does. So if I say for n in 1 through 10, right, all these numbers, print n, what this function is going to do, and I'm going to run it, is it's going to print each of these numbers. So why it's called a loop is because it takes the first number in this list right here, and it says, okay, I'm going to run whatever you tell me to do underneath here. So I indented, right? So if I put print right here, it's not gonna work because I have to indent underneath the for loop. Oops, sorry, over here, in order for it to know what to do repetitively, or in order for it to know what to loop. So it's going to say, all right, for the first number in this list, so for when n equals 1, I want you to print what n is equal to. So n is equal to 1 when n is equal to 1, so it printed 1. Now it goes back to the beginning and it says, okay, now for the next number in this list, print whatever n is equal to. Well, now n is equal to 2 instead of 1. So it's going to print 2, and that's what it did right here. Then it goes back to the top and it starts all over again, and it does that all the way through this entire list until it gets to the last number, and then it stops. All right, so what I want to do is leverage the power of this for loop in order to basically write all of the terms of this sequence without me having to do all the math myself. And so there's a couple things we need to do in order for this to work. So the first thing is, let's go ahead and just like we did before, when we were defining our recursive sequence, we have to define what the first term is. A recursive sequence only works if we know at least one of the terms. So we need to know when n equals 1, what a sub 1 is, or what a is equal to. So I'm going to go back over here, and I'm going to say, so another thing that is important in programming is if you want to write words, for example, so if I wanted to type something in words over here, if I just typed print hello, whoops, if I run that, it's going to say, I don't know what hello means. Hello is not defined. And that's because the computer is assuming that this is some type of numerical input, something that it can calculate, something like that. So it doesn't know what to do with hello. We haven't defined what hello is. We haven't told it if it's a variable, if it's a number, whatever. But if we want it to just print the word hello, we have to put it in quotation marks. Now it'll print the word hello right back up here wherever it falls in the code. Remember, it always runs the code starting at the beginning all the way through. So it's going to happen in sequential order wherever it starts. And so these quotation marks tell it, okay, no, I just want you to actually literally copy over and write out whatever I type in here. So that's what the quotation marks do. That's called a string. So a string is something that the computer just basically copies verbatim over onto the screen over here. It's not going to do any calculations. It's not going to have to reference anything. It just types it out. So that's a string. And so if I wanted to say, all right, so I'm just going to say when n equals 1, whoops, a equals 1. Let me see if that looks how I want it to look. Yes, that does. Well, actually, yeah, for now, that's going to be fine. So what this is saying is that, like we said before, a sub n, or a sub 1 is equal to 1. So when n is equal to 1, our function is going to be equal to 1, or our output is equal to 1. So that's our first term. And so now what that means is we don't need the n equals 1 term in this calculation, in this for loop, because we already know what n equals 1 is. We already know what a is equal to when n equals 1. So I'm basically going to remove that index from our list of numbers. So what this formula is going to do, or what this program is going to do, is it's going to give us the next 9 terms, because we already know what the first term is. We don't need it to find that for us. We already know it. So we're starting with n equals 2 and going to n equals 3, 4, 5, 6, 7, 8, 9, 10. All right, so we've got the first step. We've got that when n equals 1, a is equal to 1. And so the other thing that is not really intuitive for some people when they first start programming is we know that a is equal to 1 when n is equal to 1, but the computer doesn't know that because it's in these quotation marks here. So we haven't told it anything that it's going to factor in when it's running the rest of the code down here. In other words, since this is in quotation marks, the computer is basically saying, okay, I don't really need to know about what that means. I'm just going to print it out like you told me to print it out, and that's all. So I'm going to also tell the computer that a is equal to 1 right now. So that's because there's no way to do subscripts in here, so I'm not going to write a sub n, but a right now, at this point in the code, a is equal to 1. That's our first term. A starts out being equal to 1. That's our first term. So right now, the computer's, when it gets to line 10 of this code, it says, okay, a is equal to 1. But now we want to know what a is equal to for when n is 2, 3, 4, 5, 6, 7, 8, 9, and 10. And so before we do that, the other thing that I want to fix is I want this to be consistent down here. So I want it to, when it runs through this for loop 9 times, I want it to print out n equals blank, whatever n is supposed to be equal to, and then a equals whatever a is supposed to be equal to. And so the way that I'm going to do that is, instead of just having it print n, I want it to print n is equal to whatever the number is. And so what I'm going to do is, and this is another skill that's useful. So I wanted to say print n is equal to, and then I want it to tell me what n is actually equal to. So this is where it's confusing because we're using 2 separate n's. Right here, this n is the variable n. This n in red is just a letter n that it's printing out. Remember, if it's inside the quotation marks, the computer doesn't think about that as a variable. It just thinks about it as text that it's going to reprint on the screen. So every time it runs through this code, it's going to print n equals every time. And so what I want it to do is type n equals, but then I also want it to type the number that n is actually equal to. I want it to type the variable n. So whether it's 2, 3, 4, 5, or whatever. And so the way we do this, and this is another command that's useful and will be new, is the string command. So what this does is it says, all right, I want you to take whatever the number is that I put in here and turn it into a string. So imagine that I took this number and put it inside of parentheses. The reason I can't just put n equals n, let's try that first. Let me show you what I mean by this. If I tell it to type n equals n every time, it's going to run down this list and it's just going to say n equals n, n equals n equals n, because it doesn't know the difference between these two n's. I need it to know that, yeah, I want you to just print the letter n the first time, but the second time you print it, I want you to print the actual number that n is equal to. And I want you to print it as a normal string, as normal text, but I want it to actually change each time we run through the code. So this variable n changes every time we run through the for loop. It changes from 2 to 3 to 4. And so that should change this n from 2 to 3 to 4 each time. So now if I run this, now I've got n is equal to 2, and then it starts back over. Now n is equal to 3. So when it gets to the bottom, it says print n equals, but then it also says print the string version of whatever the variable is. So the variable now is 3, so it's printing n equals 3, 4, 5, 6, 7, 8, 9, 10. So this is nice. It just helps me keep track of what n is equal to for each term. But now the last step is I want to know what a is equal to for each of these terms, given that n is equal to whatever the number is. All right, so one more formatting thing is if we want to make these next 9 rows look the same as this first one. So I want them all to look like this, where I have what n equals and then I have what a equals. So I'm going to go ahead and add another string. This time I don't need to write string because I'm just writing the letter. So this is the same thing as I did with the n over here. So for each time we run through it, I want you to print n equals and then whatever n was, and then a equals, and eventually we're going to have it print whatever a is. But right now we don't know what a is. So eventually we're going to add in and have it tell us what a is, but we're not going to do that at this moment because we don't know what a is yet. So if we run this, and let me put one space there. There we go. So now we've got what n is equal to for all 10 terms, and now on the right side we have what a is equal to. All right, and so this last part is really the most difficult part for most people to wrap their heads around when they're first learning to code or when they're first learning programming. It took me a long time, so if you're not really following this, that's okay. I want you to give it your best shot and know that it takes a little bit of practice before you really get the hang of this. But essentially what we're doing here is we're saying, okay, at line 10, the computer's running these lines in order. So it's saying at line 10, a is equal to 1, right? That's equivalent to saying our first term in our sequence is equal to 1. When n is equal to 1, a is equal to 1. Now, we want to know what the next, we want it to tell us what the next term in the sequence is going to be. So it knows what a is equal to. Now it enters this for loop. And so 9 times in a row, it's going to run this code to figure out what the next term is going to be. It's going to print that term out, and then it's going to start over and calculate the next term. And so if we think about this, we said that in the recursive definition of our formula, the next term, a sub n, is equal to the previous term times 3. So we're going to take whatever the previous term was, multiply it by 3, that gives us our new term, or our next term. So we take our previous term, which was a, multiply it by 3, that'll give us the next term in our sequence. All right, so that's helpful. And before we actually run the loop, I want to show you what this will actually do. So outside of the loop, if we just say the next term is equal to a times 3, right? So the computer's running this code and it's saying, okay, a is equal to 1. Now a next, the next term, is a from before times 3. So you go ahead and tell me what should a next be equal to. All right, let's go ahead and run it and see if your prediction was correct. Oh, you know what? I made the classic mistake. I told it what a next is equal to, but then I didn't tell it to print a next. So it didn't know what to do with it. So now if we print a next, let's see if your answer was correct. So when n was equal to 1, a was equal to 1, and now a next is equal to 3. That's what it says right here. And if you want to be able to see it on the output screen better, a next equals, and then we add, and we want to make a next a string. So this is saying print out the text a next, and then add at the end a string that actually tells us the value of a next. So let's run this. There we go. So a next is equal to 3, right? We took the first a, we multiplied it by 3, and now we've got our next term is a equals 3. I know this is confusing. I'm trying to break it down into as many pieces as possible so it's as easy to understand as possible. So that's what this code is going to do right here. It's going to say the first time I run through, when n equals 2, I'm going to take whatever a was, multiply it by 3. That's going to give me a next. So now I'm going to tell it to print n equals, just the text n equals, plus the string and tell us what n actually is. We already did that. And then tell us what a equals. And then I want to print the string value of what a next is, what the next term is. So plus the string of a next. So in other words, I want it to print a equals and then tell me what a should actually be equal to. And that's equivalent to the next term. What should the next term be equal to? So if I run this, there's a problem. Every single term it says a should be equal to 3. Well, we know that's not the case. We know that when n equals 3, a should be equal to 9, and when n equals 4, a should be equal to 27. So something's going wrong here, and let's think about what's going wrong. Because what the computer's doing is it's looking at this for loop, and it's saying, all right, when n is equal to 2, I'm going to say a next is equal to whatever a was. So a is 1 times 3. I'm going to print out n equals 2 and a equals 1 times 3, which is 3. Now I go back up here, a is still equal to 1. So when it runs through this code again, when n is equal to 3, it's going to run through, it's going to say, all right, a next is equal to a, which is still 1 times 3. And it's going to print out n equals 3 and a equals 3 again, because 1 times 3 is still 3. So what we have to do is we have to redefine what a is equal to now. So now our new a is equal to whatever a next was. And this is the piece that I think is most counterintuitive, because what we're essentially doing is we're redefining the variable a. So now instead of a being equal to 1, a is equal to whatever we just found a to be equal to. Whatever the next term was, that's our new a. So now when the program starts over, it's going to say, all right, I'm going to take when n equals 3, a next is going to be equal to whatever a is. Well, a is no longer 1. We told it a is not 1 anymore. A is a next, which is the term that we finished with the last time it ran through. So now it's going to take the previous term. It's going to take 1 times 3, which was 3. It's going to take a equals 3, and it's going to multiply that by 3. It's going to multiply our new a by 3. And then it's going to print out n equals 3 and a equals whatever a should be equal to, which should be 9. Then it's going to redefine a again. So now it's going to redefine, now a is no longer 3, a is 9. So let's run it and make sure that this works before I keep going. Good, so it worked. So now it's run through and it says, okay, now a is equal to 9. I've redefined a is now 9. So now I'm going to go back up to the beginning. N is now equal to 4, right? It's running through each of these in sequential order. So now we're at n equals 4. A next now is going to be whatever a was previously times 3. So, and I know there's a lot of numbers in here. I'm probably not doing the best job of explaining it, but then it runs back through and multiplies whatever the previous term was by 3, and it spits out the new term, which is 27. It goes all the way down, and we go all the way to n equals 10. We could add numbers to this. We could add as many numbers as we wanted and run it, and it'll give us 14 different terms of this sequence. We could go as high as we wanted to, and I'll actually show you one last command that's pretty useful. Is instead of typing out all the numbers ourselves, let's say you wanted to know the 101st term and you don't want to type 2, 3, 4, 5, 6, 7 all the way to 101, there's a command built into Python called range, where what this command is telling it is saying, all right, take all the numbers from 0 to the number right before this number. So it doesn't include the number in parentheses, but all of the numbers before it includes. So this should take us all the way to term 101. And just look at how fast the computer does this. Also, look at how fast this number grows. I mean, that's an absurdly large number. But the computer did this in less than a second. And it would take you hours and hours to multiply all these numbers out and find the 101st term of the sequence. The computer just did it in a matter of half a second. And that's one of the most powerful things, and that's one of the reasons why computers really have changed the way we do so many things, is because it automates so many processes that took us so long. All right, so that was just a very brief introduction to some programming terminology and skills, and also a nice little review of some of our sequences and series. Well, this video is all sequences. What I'm actually thinking about doing is maybe posting an optional video where we go into some more programming stuff, looking at series. And that might be something that if this was interesting to you and you'd like to learn more about this, there's obviously a million resources online, but I am considering posting an optional video where we go into some detail about some programming stuff with series as well. So I hope that was kind of interesting. I hope it kind of piqued your interest in some programming stuff if you've never thought about it before. This is a skill that is going to be very valuable in the years to come, and I really think that The earlier you can start learning a little bit about it, the better. So I hope that was fun. I hope that was helpful. And thank you guys for your attention. And I will see you in the next video.